more than 60 years of protecting a land on the edge of the Tengger Desert. Before me lies the Tengger Desert, a vast sea of sand stretching across Ningxia, Inner Mongolia, and Gansu. Under the early morning sun, the dunes turn a brilliant golden color and continue all the way to the horizon. The wind sweeps across the surface, lifting the sand into thin streams that look almost like smoke. The landscape is so beautiful that it is easy to forget that this place was once a serious threat to thousands of families living along the edge of the desert. Sand does not remain still. Driven by the wind, layer after layer of sand continuously moved toward the railway, farmland, and residential areas. At certain times, a section of track would be cleared, only to be buried again after a single strong storm. Trains were forced to slow down or stop while workers removed the sand and inspected the railway bed before the journey could continue. Each interruption caused more than delay. It created safety risks and disrupted one of the region's most important transportation routes. Their original hope was actually very simple. They only wanted to stop the sand from covering the tracks so trains could pass safely and reliably. But once the problem was studied more closely, it became clear that this was not only about the railway. If the moving dunes could not be controlled, villages, farmland, and the entire way of life along the desert's edge would remain under constant threat. In 1959, the problem began to be studied in a systematic way. A research center dedicated to testing methods of sand control was established in the Shapotou area. Instead of continuing to remove sand after every storm, researchers began searching for a way to stop the sand from moving in the first place. From that process, 5 main goals gradually became clear: protect the railway, stabilize the moving dunes, introduce drought-resistant plants, build windbreak belts, and finally, restore the ecosystem while creating livelihoods that would allow local people to remain on the land. The first thing they realized was that trees could not simply be planted on sand that was constantly shifting. Young plants could easily be buried. In other places, the wind removed the sand around their roots, leaving them exposed until they dried out and died. If plants were going to survive, the sand first had to be stabilized. And the most famous solution developed here was surprisingly simple: straw checkerboards. Straw was inserted into the sand in square patterns, usually measuring about 1 meter by 1 meter. These low straw barriers reduced the speed of the wind close to the ground. As the wind slowed, grains of sand fell and remained inside each square instead of being carried farther away. The surface gradually became more stable, moisture was retained more effectively, and grass seeds and shrubs finally had a chance to take root. A single straw square could not stop a desert, but millions of connected squares could change the way the sand moved. If you find this solution remarkable, leave a comment saying, "It started with 1 square." Because this story shows that great change does not always begin with a giant machine. Sometimes it begins with one small action, repeated correctly for long enough. From a distance, the millions of straw squares look like a giant chessboard spread across the desert. But when I stand close to them, I no longer see a beautiful geometric pattern. I see human effort. Each square represents someone who once bent down over the hot sand. One person carried the straw. Another measured the distance. Someone else pushed the straw into the ground. Others returned later to repair the sections damaged by the wind. They did not try to defeat the entire desert in a single move. They divided an enormous problem into millions of smaller ones and solved them one by one. After 1978, when the 3 North Shelter Belt program was launched, the scale of the campaign expanded even further. Desert control was no longer the responsibility of only one research center or a small group of engineers. Communities along the edge of the desert began mobilizing residents to build irrigation systems, plant vegetation, construct windbreaks, and stabilize the moving sand. During the dry season, before the strongest sandstorms arrived, groups of people carried straw, shovels, and basic tools deep into the desert. There were no smooth roads and no shade from the sun. Every bundle of straw had to be carried across soft, burning dunes. At the work sites, people knelt on the sand, cut narrow lines into the surface, and inserted the straw into evenly spaced squares. One person working for a single day could only create a tiny section, but when thousands worked together, and when the effort continued across generations, those tiny sections became part of a much larger system. This is not the story of one extraordinary individual. It is the story of ordinary people doing difficult work for a very long time. Some spent their entire youth trying to hold back the sand. In some families, parents joined the early planting campaigns, and their children later continued managing the same protective forests. The results we see today do not belong to one generation. They were created through continuity. Once the sand had stabilized, people introduced drought-resistant grasses, shrubs, and windbreak trees. Each layer of vegetation had a different role. Grass covered the surface, shrubs anchored the dunes. Taller rows of trees reduced wind speed and protected the land behind them. Dead plants were replaced. Damaged straw barriers were repaired. Areas that remained unstable were reinforced again. This process did not take place over one season. It continued for years, and in many places, for decades. What is especially important is that they did not try to turn the entire desert into a forest. A natural desert is also an ecosystem. Not every area is suitable for large trees. If the wrong species are planted, if the density is too high, or if too much water is used, the plants may die and water resources may decline. That is why the solution had to be adjusted to each location. In the driest areas, only grasses or low shrubs were planted. In places with better access to water, greenbelts and agricultural zones could be developed. Success did not come from blindly fighting nature. It came from understanding nature's limits and working within them. Water played a vital role in this entire transformation. Ningxia has a unique advantage. The Yellow River and an irrigation system that has existed for more than 2,000 years. Since the Qin and Han dynasties, ancient engineers built canals to support settlement and agriculture, including what are commonly known as the Qin Canal and the Han Canal. Water from the Yellow River was directed through the Qingtong Xie area and distributed to lower-lying land. What impresses me is that ancient builders understood how to use the natural slope of the terrain to create gravity-fed irrigation. Because of this water, many dry parts of Ningxia became productive farmland, earning the region the name the Jiangnan beyond the Great Wall. In modern times, those ancient canals, together with newer irrigation networks, continued to support settlements, farmland, and ecological protection belts along the desert's edge. In 2017, the ancient Yellow River irrigation system in Ningxia was recognized as a World Heritage irrigation structure. Standing here, I feel as though I am watching two different eras meet. On one side is more than 2,000 years of irrigation knowledge. On the other is more than 60 years of desert control. The ancestors left behind the water. Later generations used that water to protect the land. As the sand became stable, the water was managed more carefully, and vegetation began to take hold. Green life appeared slowly. At first, there were only a few patches of grass. Then came shrubs. Over time, windbreak belts began to connect. Plants held the soil. The soil retained water. The water helped more plants grow. A new cycle began to form on land that had once been almost entirely sand. But if environmental protection only created costs, it would have been difficult for local communities to continue the work across generations. That is why another important change took place. Families were given land use responsibilities, contracted to manage protective forests, and allowed to grow economic crops suited to the dry climate. From that point on, they were no longer simply joining short-term planting campaigns. The future of their families became directly connected to the stability of the land. If the plants survived, they earned income. If the land remained stable, they could continue farming. If the greenbelt was protected, the villages and roads behind it were safer. This connection between ecology and livelihood transformed desert control from a costly obligation into a system that could be maintained over the long term. In Ningxia, goji berries became one of the clearest symbols of this model. This hardy shrub can tolerate dry conditions and certain types of saline soil. Its fruit is used in food, traditional medicine, and a wide range of processed products. Over time, goji plantations appeared on land that had once been considered barren. Behind those fields came facilities for cleaning, drying, sorting, packaging, and processing. A plant that could survive the environment while also creating economic value gave local people a strong reason to continue protecting the land. Other areas also developed wine grapes, Chinese dates, and cistanche, a valuable medicinal plant. The outer zone was used to stabilize the sand. The inner zone became productive farmland. Behind the agricultural areas came factories, transportation networks, and markets. At this point, desert control was no longer only an ecological project. It had become part of the local economy. If you have ever thought that protecting nature simply means planting trees, share this video with someone else. Because this story shows that land can only be protected for the long term when local people can live on it, work on it, and see a future there. After more than 60 years, the results can be seen in specific numbers, according to the data used in this script. In some areas around Zhongwei, the boundary of moving sand has been pushed back by approximately 20 to 25 kilometers. Vegetation coverage within restored shelter belts has reportedly increased from below 1% to around 18%. More than 370,000 hectares of moving sand, equivalent to roughly 3,700 square kilometers, have undergone stabilization and restoration. An ecological belt approximately 153 kilometers long has been created, with a width ranging from about 10 to 38 kilometers depending on the location. These numbers only become meaningful when we place them beside the amount of time involved. Pushing the sand back by 20 kilometers was not the result of 1 year. Restoring 3,700 square kilometers of land was not the outcome of a single campaign. A 153-kilometer ecological belt could not have been created through a few symbolic tree planting events. It was the result of more than 6 decades of research, experimentation, failure, correction, rebuilding, and maintenance. By the middle of 2025, according to the information used in this script, important sections of the Green Barrier System in Inner Mongolia had also been completed, helping control the movement of sand from the Badain-Jaran, Tengger, and Ulan-Bu deserts. But I do not believe the greatest achievement is the length of the belt or the area of land restored. The greatest achievement is continuity. The people who placed the first straw squares may never have seen the modern goji processing factories of today. Those who planted the first lines of windbreak trees may never have witnessed the desert boundary retreat by dozens of kilometers. But they still began the work. One generation held the land. The next planted more vegetation. The following generation built livelihoods. Each generation completed only one part, but those parts eventually became a transformation that no single person could have achieved alone. Standing here, I can see two worlds beside each other. On one side, the Tengger Desert remains vast and powerful. On the other, there are railways, communities, goji plantations, and farmland irrigated by the Yellow River. The desert did not disappear. Human beings did not truly conquer nature. They simply learned to understand it, adapt to it, and create a boundary strong enough to protect their lives. I once believed that great human achievements had to be made of steel, concrete, and giant machines. But here, one of the most remarkable projects began with bundles of straw pushed into the sand. One bundle of straw is very small. One person is also very small when standing before an entire desert. But when many generations continue doing the right thing for long enough, they can change the path of the sand itself. If you enjoy stories about nature, human resilience, and places transformed through patience, like this video, and subscribe to the channel. There are still many parts of the world where we only understand the true value of persistence when we look closely enough. More than 60 years. Around 3,700 square kilometers of moving sand stabilized and restored. An ecological belt approximately 153 kilometers long. In some areas, the desert boundary pushed back by 20 to 25 kilometers. Behind those numbers was no miracle. There was science, labor, and the determination of many generations. And perhaps the most important lesson from this land is this: some achievements cannot be completed within a single lifetime. But one generation must still have the courage to begin.